As we talked about, we're starting a new unit on logic. When we talk about inductive reasoning, hopefully you realize that this is talking more mainly about recognizing patterns or the experiences that you have. We just talked about some of the things that you learned as a child, such as recognizing the motion of something when you turn it on, noticing that if it's cloudy outside, it's probably cooler or it might rain. Things like that are things that you recognize. Geometry is rooted in inductive reasoning. It's based on inductive reasoning. Okay? In ancient Egypt and Babylonia, geometry began when people developed procedures for measurement after much experience and observation. Okay? The actual term geometry means the measure of the earth. They created geometry because, like the Nile, think of the Nile River, it would flood every single year if you owned land. Well, all of a sudden that land was underwater, and then like the water would recede. It's not underwater anymore, but you'd be like, ooh, where was my property? Because every single year it would flood and your land would be under the water, and then it would be not underwater anymore. You had to figure out, well, the little markers I had are now gone. How do I figure out again? And basically they created geometry to be able to figure out, well, it's based on this parallel line or this perpendicular line, or it's based on, this specific distance. They were measuring things in order to determine whose land was where. That's how it was created. Okay? Geometry was originally inspired by the ancient Egyptians, who devised a complex system of land surveying. That was what I was just talking about. In order to reestablish land boundaries that were erased by this. Oh, that was just talking about this. This is good. Engineers used procedures to build canals, reservoirs, and the Great Pyramids. When you use inductive reasoning to make generalizations, the generalizations are called a conjecture. And then there's also a hypothesis. Hypothesis in science class is very similar to a conjecture now. Okay? We're going to talk about sequences. The directions here say consider the following sequence, make a conjecture, and write a rule of the sequence, then find the next terms. Okay? So if we have 1, 3, 5, 7, 9, first off we need to write some sort of rule or express some sort of rule. Somebody have raise their hand. What are we doing here? Yeah, so we're saying like n, let me say n equals n minus 1, wow. N plus 2. N minus 1 plus 2, okay? It says whatever your previous n was, and you're going to add 2 to it. Because this means like the next term. Maybe we should write it this way. I'm going to rewrite this. Sorry. Wow, that didn't work. Okay, you could say your next term equals whatever your last term is plus 2. And that was the exact notation that I have. So if you're going to talk about n as like, say, 5, what was the term right before 5? It was 3, so that's like the last one. So that's like the term right before it. And we're going to add 2 to it. So basically this is the current one, like I'm not even going to write this. This is notation you have not seen before. It's notation that's talked about in Algebra 1 and Algebra 2, but we're not going to write that. We're just going to write next equals the last plus 2. How's that? The next one, how do we do this next one? Someone tell me, oh wait, we need to come up with the next 3 terms. We'll count after 9, 11 after that, 13, what after that? 15. Okay, next 3 terms we should be good. Number 2 says 2, 4, 7, 11, 16. What's going on there? Someone raise their hand. You raise your hand and then wait for me to call on you. Anybody know what's going on? Please, say them. So we add 2 right here. Yeah. Then what would we do? Add 3. Then what would we do? 4. Add 4. Then add 5. So we're adding consecutive integers is what we're doing. How are we going to write that rule? N plus. What do you think?
Next equals last plus 1 each time.
Yeah, it's kind of tough to describe it, isn't it? So here's what I'm going to write. I'm going to write the next term equals the last term. Then we're going to say plus. I'm just going to write consecutive. We talked about the word consecutive. integers. Consecutive integers. So that means that first we're gonna add 1, the next one we're gonna add 2, then we're gonna add 3. We start at 2, but it's sort of a general rule. So what would the next term be? We're gonna add 6 to it, so what would that be? 22. You're adding 6. We're gonna add 7, so what would be after that? 29. We're gonna add 8. 37. 6, 7, and 8. Okay. Let's see. This is 1 over 1, 1 over 2, 1 over 3, 1 over 4. Pattern. The next equals basically 1 over. This would be consecutive integers.
That's 29. Sorry.
That says 29. That says 37. Yeah. So we'd have what? 1 over 8, 1 over 9, and 1 over 10 would be the next ones. Is that right? Okay. A-E-I-O-U, A-E-I-O-U, A-E-I-O-U. Yes, you do owe me.
Yeah, right.
Okay. You're doing like what? Consecutive vowels, something like that? I guess consecutive vowels. Okay. What are we doing this next one? It says -1 and +2, -3, +4, -5, +6, -7, +8. What would the next one be? -9. Then what? +10. Then -11. So it's oscillating back and forth, positive and negatives. Positive and negatives, right, Ty? Okay. And then basically we're just going up by 1 each time, right? So it looks something like this. This is next at equals. We're basically having like the last one +1, and then check this out. Then we have to do something like -1 to the like n. It's ridiculous. So it's really tough to represent with a formula. When you get into algebra 2, you'll be writing formulas with this, and you'll be great. What about this next one? 6. Seems like it's like just random letters, right? Except when we look at. Sure. Why don't you say the answer? See if people can figure it out.
It's O and
O, N, and D. I agree. O, N, and D. Raise your hand if you have it.
how you know do
What
this?
if I-
Can I just say it?
What if I told you you're there right now?
Can I just say it?
There's 12 of them up there right now.
There's 26 in the alphabet.
Yep, it's not 26 in the alphabet.
12
What has
months.
12 months?
January, February, March,
12 months.
April, May.
January, February, March, April, May, June, July, August, September, October, November, December.
Good.
I'm smart.
Wow.
Write your own sequence. Write your own sequence of 5 or more terms. 5 or more terms. Everyone do this. Write your own sequence.
It's complicated.
Have your neighbor make a conjecture. Why don't you guys just take a little while to do this? I want to make sure that I can get the next part up for us. Yes, ma'am. Probably in the morning. I know, it's not really helpful, is it? And tomorrow morning I don't get until about 6:50. Because otherwise I'm just working. I would go online or go to Mrs. Gant after school. Online has all the answers and how to get to them. Everything, yeah, that's what solutions are. You're welcome. I'm sorry, I wish I could help more.
That's my best friend.
Yes, you can. I had some, someone stole it.
No, I don't know how to.
You guys are writing your sequence. Why don't you guys share your sequence with the person next to you right now?
What's yours? Mine is M.
Rashad just took the last one, I guess. So I do not. Would you like to go to the restroom? Why don't you go to the restroom right now?
Well, okay.
That's the best I can offer you right now.
I like the drone making it for the last time. It's fun. And I showed it to Mario. Yeah.
Turn around. Did you go to concerts?
I did not. I was very hot topic.
Okay, it sounds like you guys have shared your sequences. I really appreciate that. Turn to the next page. Turn to the next page. On the next page, it says use inductive reasoning to find the next term in the sequence and explain the pattern used. Brett, it says 2. It says 16, 128, and 1024. What in the world is going on there?
We ain't got that, bro.
Okay, hold on a second. No, mine's what I'm showing you the homework. This is perfect. Nope, that's still the wrong one.
That's not the yeah, right here. Right here. That's great. Keep
That's
it like
wonderful, yeah. Hold on a second. Let me get the right thing up here.
You got so many tabs.
Tell me about it. I know. I'm that popular. I know.
Oh, show that.
I know.
I'll give you.
Someday.
I'll make it show you.
Okay, let's try this again, guys. Here we go. Whoops. Here it is. Okay. Is this what you had? No? Still not that? That one? Okay, thank goodness. Here we go. Time. We have. Ridiculous. We have 2, 20, 200, and 2,000. What's the next one going to be for us, please? 20,000. Okay, now here's the tough part. You just wrote that part out, but now you still need to go through and explain the pattern used. So what's going on? You have to write it in your own words. Okay, add a 0 on the end. Who's they? The person that made it. Okay, so you need to probably, I would probably try saying something like using next term or previous term, something like that in your sentence. So what would you do? You'd say something like multiply by 10, wouldn't you? Or add a 0? Because adding 0 is something someone could just say, well, it would always be the same number because you're always adding 0 to it. So how might you say that, Ty, in real words, saying using next term, previous term, something about times 10? How would you put that into one sentence for us, please? I'm going to write it down for everyone to see.
What do you do?
Thank you very much. So every single one of these should say something about the next term is the previous term, and then when you're going to describe it in some way, multiply by 10. Sometimes you say twice the previous term plus 2, or whatever's going to go on. This one, the next term is the previous term multiplied by 10. That's perfect. That is so good. Okay, the second one. Hopefully you've been looking at this just a little bit. Who has the second one? What's going on there? Please, what do you have, Lachey? You had 50. Okay, I'm going to write 50 down. Tell me this pattern. What's going on here? So you were adding 3, then we add 5, we're adding 7, oh boy, 9 is getting bigger, plus 11 here, that's going to be plus 13, right? So how do you say this in words? I'm going to write a different color here. The next term is the previous term. Now, what did we call these? So we'd say plus consecutive. Now, are they just numbers or integers, or are they odd numbers? What are we talking about? So we say consecutive odd integers. I'm hoping you guys are writing these down just as I'm writing them. Yes, ma'am.
What is consecutive?
Consecutive means in a row. So, like 3, then 5, and 7, and 9, and 11, and 13, if we're just talking about the odd ones. So it's like the next one that we think they would come. Okay? We talk about consecutive, it mean like this. Where the shape that said A, B, C, D. What will be the next consecutive letter after D? E, right? So when you do this, it just means you're going around in order, is what consecutive means. You're welcome. The third one. You're hungry. Thank you for being hungry. If you're hungry, you're going to do number 3. What's going on here? You're adding 3, and then you add 2, okay, then you add 5, then you add what? Okay, so are you noticing some sort of pattern again?
Yeah.
So you're adding 3, you're adding 2, then you're adding what? 5, then you're adding 7, then you're adding what? 12, then you're adding what?
I don't know what this is.
19?
Unconsecutive?
I don't know about that. That doesn't really seem like a pattern to me.
Me neither. It just
Okay, what else do we have? If it's not adding something, what else could we be doing? Multiplying, okay. Let's see what multiplying looks
No,
like.
you can't times nothing to get 5.
Okay, Mitchell, if we're not adding, we're multiplying, so 2 times what gives me 5?
2 times 2 minus 3 minus 1.
Times 2.5? I don't know. What would this give us? We're minusing?
Times 3 minus
It's called subtraction, but yes, we're subtracting. We're minusing. So Justin, how are we subtracting?
I just
Minus 2 is 3, 7 minus 2 is equal to the last number, everything is fine.
Okay, so you're actually adding the previous number, right? So 2 plus 5 equals 7, right? And 5 plus 7 equals 12.
yeah, bro.
7 plus 12 equals 19.
Yeah, I got it.
Okay? So you might say something like this. You might say, the next term is the sum of the previous 2 terms.
That's too much.
Okay? So we basically have to add 31 and 50 together to get the next term. So what's the next term? 81. I totally agree with that. Okay, so you're adding, this is a pretty famous concept here of adding the previous 2 terms together. It's called the Fibonacci sequence. It's kind of the idea. Generally speaking, it starts off with ones. It's like 1, 1, 2, then 3, then 5, then 8, then 13. It just keeps going on forever. Yes, ma'am.
So how did they get 5 out of just the 2?
You have to be given the first 2, and then you go from there.
But then how would you get the first one?
Number 3.
Well, they give you the first 2. The first 2 have to be there. Whenever you write a sequence, it always says, hey, list at least 3 or 4 or 5 terms to start off with. So basically, they would give you this much, then you can go with the pattern. But yeah, you have to start there. Because we can start this anywhere we want. If we started with 1s, if we started with 1 and 1, we would get 2. Then we'd be able to add the next, that would be 3, add those 2, 5. But they have to give you numbers to start off with. Okay. Sometimes patterns can also be visual as well. Okay? So, it looks to me like for this one, well, it looks like we always start off with this part here. Okay? And then what we do, if you're picturing them as blocks, we're going to add 1 block to the right, we're going to want to block back. Is that correct? Okay, so that's the second one. We add 1 block this way, 1 block back. So then what happens here is we have to draw the exact same thing. So that would look something like this. Hopefully you can draw yours right near mine. We have 3 going this way. We have 1, 2, 3, 4.
Nobody tweets.
You gotta go as far down.
That's pretty good. I like
Oh, except for that line right
it. Yeah,
there.
it's a little close. There we go.
That's the one better.
That's still pretty good. I'll give that an 8. Alright.
Okay, so in this case, that wasn't too bad. So the idea here is that our previous terms, we had this stuff right here. These guys right here. Those are the ones we had. And we basically needed to add one block back and one block to the right. So the same thing goes on here. From here we had 3 up front, now we have 4 up front, and we have an extra one going back. Okay? So we're noticing patterns that can be visual. Number 5. What is going on for 5?
I don't know.
So we have one line. What is this called?
Diameter.
Okay, it's only a diameter if there's a center in the if there's a center there. So instead of that, I'm going to say it's just some sort of chord. Okay, it's a chord. Then we basically cut that chord in half, right? So we cut that chord in half. And then I would expect, you know, if we're going to continue cutting chords in half, we have to cut this chord right here in half somehow. This part, this little line in half, this line in half, and this line in half. And somehow we need to end up with that. Holy smokes. So I know for sure that we have this line with this line. So those are what we have over here, right? So it looks to me,
Just got that half on too.
it looks to me like we would probably add this line right here. Because that would cut both these guys in half. Probably shade this line in. And we probably also have, let's see. I guess we're just adding one each time. You probably just have that.
I think
Sorry, that should have gone right here. Because both those guys in half. Okay. So you guys are noticing patterns. We're going through this. There's still 2 more on here, right? 6 and 7.
Yep.
Oh boy. There it is. Is this the right one?
Yes.
Okay. So you're finding the nth term of the sequence is actually writing. This is the part that I was trying to get you guys to do earlier. Is we're actually trying to write this in terms of some sort of formula. So here's what we have. Maybe this is more difficult for you guys. I don't know. This is definitely something I do in AG2. I'm not sure if your teacher did or not. We'll see how this goes. This is term 1, 2, 3, 4, 5, 6. What's going on down here? We're basically adding 1, right? So if you've not paid attention this far in the class, maybe this is a good time to start paying attention.
Yes.
This is definitely something that we'll use later on. Looks like we're adding 1 each time. Okay? So when I do this, I'm actually going to just say n, and I'm going to say times 1. We're going to see how this works out here in just a second. I'm going to say times 1 because you're going to multiply by whatever this number is down here. Okay? So hold on a second. But I know. But where do we start off? Where were we at for 0? Where would the 0th term be? If there was a 0th term, what would the value be?
7.
It'd be at 7. So I'm going to say this is 1n plus 7. Okay? So what happens is, you always have n, it's always multiplied by whatever you're adding or subtracting. So if you're always adding 1, you're going to multiply by 1. If it's subtracting 1 each time, you have negative 1 up here. Okay? And this is always the 0th term. Always. 0th term. Okay? And you can test this if you really want. They give us the 3rd term. So all we have to do is say, substitute n in here. So that's 1 times 3 plus 7. 1 times 3 is 3 plus 7 equals 10. Is that what it is? Yeah, it's 10. So we're good. Alright, this next one. What's going on here?
The one up there.
So we're adding 5 each time, is that right? Each time. So if I was to write this, what am I going to multiply n by? 5. You always multiply with whatever you're adding or subtracting like that. If I was to find the 0th term here, the 0th term, I have to step back, so I'm sort of subtracting 5, subtracting 5, subtracting 5, subtracting 5. subtracting 5. Here I just subtract 5 more. What's 2 minus 5? Negative 3. So what do I put over here? Minus 3. Okay. And if we were to test this, let me just pick this guy right here. I would say that's 5 times 5 minus 3. That's 25 minus 3. That equals 22. Is that what it says right here? It does. Okay. So you're actually writing a formula based on this. You would always multiply by whatever's down here. And you always add whatever's the zero first. Your homework is very similar to this last sheet that you guys just had. In fact, it was so similar I actually accidentally was given it to you as part of the notes.